All right, so this video is going to cover this practice loops, and we got all the information, and we just need to determine the output. All right, so we got B is 24, C is 12. While they're not equal, which is true, we will print B is 24 and C is 12. We'll add 1 to B. We'll add 1 to B and 6 to C. So next time through, they're not equal, so it'd be B is 25 and C is 18. They're still not equal, so B is 26 and C is 24. Okay, still not equal, so B is 27 and C is 30. And you can kind of see B is 28 and C is 36. And you can see dot, dot, dot that it's going to end up being an infinite loop. Infinite loop. Because they're never going to be equal, and since they're never equal, it's just going to run through this the whole time, and then, you know, your compiler would never end, and it would spit this out, you know, forever. So anyway, that's the first one. All right, second one. Now, this one would be hard to do. You wouldn't want to go through this the entire time. Let's look at this. You got a bank is 3,000, car is 4,000, hours is 0. While your bank is less than the car, so the idea is that you got a certain amount of money in your bank and you need 4,000. You got 3,000. Once you have 4,000, you can buy your car. And it looks like each hour you make 12 bucks. So, you know, hours are 0 right now. But when you work an hour, your bank goes up by $12. That's what this program's trying to do. So you're trying to figure out you worked how many hours to buy your car. Okay. Now, you could go, you know, 1,012, 1,024, 1,036, 1,048, right? All I'm doing is adding 12 to it. Or sorry, it'd be 3,012. So, you know, bank would be 3,000 initially, then it'd be after 1 hour of work, 2 hours of work, 3 hours of work, 4 hours of work. Okay, you could do that, but that's too much work to do. And so you actually probably want to use a calculator to figure this out. So if your car costs 4,000 bucks and you subtract 3,000 from it, you need to get $1,000. Well, you make $12 an hour, so divide that by 12. So you need to work 83 and a third hour. Really, it's just 84 hours because, you know, that'd be a full hour. Okay, so basically, this would say you worked 84 hours. Because we're dealing with ints, we're not dealing with doubles, so 83 wouldn't be enough, so because it chops off the 0.33. So you really have to work 84 hours. You worked 84 hours to buy your car. Okay, that's what the output would be. Okay. Next up, ooh, this one's kind of a hard one. So I would look at, what's the best way to do this? The output is just going to be what this prints. So you're taking whatever value of k is, but you probably want to keep some sort of counter of what k is. K is 0 initially. And you probably want to keep a counter of m. And m is -2. Okay. So m is -2. As long as m is less than 1, -2 is less than 1, then we do k equals k is equal to, yeah, I should have done it like that. K is equal to k plus m times 2. So what do we have? We have 0 plus -2 times 2. So -2 times 2 -2 times 2 is -4. Yeah. So k becomes -4. Okay. And then we output 4 times 4 times -4. So then I should probably put the excuse me. Excuse me. Wow. S.O.P. And this is what? 4 times k. So it would output -16, right? 4 times -4 is -16, okay? So then what do we do? K is -4. Then we got to add, so we get done here, we got to add 1 to m. M becomes -1. So I've got, what, -4 here. -4 plus -1 times 2. -2, or so this is -2 plus -4, and that's going to give me what, -6. So k is -6. And then 4 times -6 is -24. Then we add 1 to m. M becomes 0. So we go here and we've got -6 plus 0 times 2, right? 0 times 2 is 0 plus a -6. So that gives us a -6. So again, we do 4 times -6. We get -24. So in this case, x or k is still -6. We add 1 to m. So now our equation looks like this. You got -6 plus 1 times 2. 1 times 2. And by the way, 1 is less than or equal to 1. I didn't really go through that, but on all of these, you can see how all of these are less than or equal to 1, so it processes everything inside the for loop. So you got 2 plus a -6 is going to give us what? It's going to give us a -4, right? And so 4 times -4 is negative 16 again. So it's going to output negative 16, negative 24, negative 24, negative 16. We got the nested loops. Okay, so remember, nested loops are kind of like your bicycle gears, where you have an outer loop that runs once in this case. So I is 1, 1 is less than or equal to 7, so it runs once, and then j is equal to 1, and so 1 is less than or equal to 7, so you're going to add this up, so it's going to go 1, 2, 3, 4, 5, 6, 7. So this inner loop will run in this first one 7 times and print that, okay? And let's think about this. J is 1, so is 1 less than or equal to 7? Yes, so we then print a $sign. Add 1 to j, j becomes 2. Is 2 less than or equal to 7? Yep, so it prints a $sign. Add 1 to j, j becomes 3. Is 3 less than or equal to 7? Yep, $sign. All the way up to is 7 less than or equal to 7, so I need to do, that would be $7 signs, okay? Then j would become 8. Is 8 less than or equal to 7? No, so you're done with this loop, and then you print a new line. So your cursor goes from where it's at right here on this line, next to the dollar symbol, to the new line. Okay, so your cursor's right here on the output. Then it goes up, adds 1 to I becomes 2. Is 2 less than or equal to 7? Yep. So you go in here again, and j becomes equal to 2. So is 2 less than or equal to 7? Yep. So then print a dollar symbol. And then add 1 becomes 3. Is 3 less than or equal to 7? Yep. Then 4, then 5, then 6, then 7. So you print 1 less. Okay. So you can kind of start seeing the pattern here. J would become 8. 8 is not less than or equal to 7, so you're done with this one, and then you print a new line, and so now your cursor's down here. Then you add 1 up to I becomes 3. So is 3 less than or equal to 7? Yep. So then j becomes 3. Is 3 less, or so j is 3. Is 3 less than or equal to 7? Yep. So you do a star. Then it becomes 4, 5, 6, 7. Then it prints a new line. I becomes 4, and then j becomes 4. Is 4 less than or equal to 4? Yep. So you print 4, 5, 6, 7. And then you can kind of see how this is going to play out. And you kind of know this because your outer loop, I is less than or equal to is 1 at first, and it's less than or equal to 7. So there's row 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7 rows. Okay. And each time I is growing by 1, so it's printing 1 less dollar symbol here. So oh gosh, this one's a miserable one. All right, so let's look at this. All right, so say m is 1, m is 1. Is m less than 5? We got n. So is 1 less than 5? That's true. Then you've got n is 5. Is n less than or equal to 20? And you're going to add 5 to each. Okay, so Then we got our if statement. Okay, let's see here. I might have to move this over in order to. Okay, then we got what? S.O.P. And then what? M plus N. So M plus N. Let's make this a little bit larger. There we go. All right, so so 5 is less than or equal to 20. So M is 1 and N is 6 modulus 3 equal to 0. How many times does 3 go into 6? It goes in 2 with the remainder of 0. Yes. So it prints. It prints M is 1, so 1 plus 5. Okay. Adds 5 to N. N becomes what? 10? Is 10 less than or equal to 20? Yep. So then we have what? 1 plus 10 is 11, right? So, 1 plus 10 is 11. So what's 11 modulus 3? It goes in, what, 3 times for the remainder of 2? Is that equal to 0? No. So then it doesn't print this at all. So then we add 5 to 5, and this becomes 15. 15 is less than or equal to 20. So then we got 15 plus 1. First, 1 plus 15 is 16. Does equal 0? Nope. Because 3 goes into 16 3 times with the remainder 1. So then it becomes what? 20. Is 20 less than or equal to 20, let me see here. It's 20 less than or equal to 20. Yep. So then we got 1 plus 20 is 21. 21 modulus 2, or modulus 3, that is equal to 0. So then it's got 1 1 plus 20. Okay. N becomes 25. And is 25 less than or equal to 20? Nope. So you're done with that. N becomes 2. Is 2 less than 5? Yes, it is. So then N becomes 5 again. And is 5 less than or equal to 20? Yes. So you've got 2 plus 5 is 7. Is 7 modulus 3 equals 0? Nope, it's not. So it skips the print. N becomes 10. Is 10 less than or equal to 20? Yes. So you got let think here. 2 plus 10 is 12. 12 modulus 3, that is equal to 0. So, and maybe I should just... Maybe I'll put a not in front of this. I don't know. I'm trying to differentiate. That is equal to... So this would print what? 2 plus 10. Well, then you'd have 15. 15 less than or equal to 20. Yes, so then you'd have 15 plus 2 is 17 modulus 3. That is not equal to 0. So you'd skip that. And then you'd have, what, 20 here? 20 is less than or equal to 20. It's true. So you have 22 modulus 3. Modulus 3. And that is not equal to 0. So then you'd have 25 is 25 less than or equal to 20. No. So then becomes 3. Is 3 less than 5? Yes. So n becomes 5 again. And is 5 less than or equal to 20? Yes, it is. So then you'd have 5 plus 3 is 8. 8 modulus 3 is not equal to 0. So you'd skip that. N becomes 10. 10 is less than or equal to 20. So you got 13 modulus 3. It's not equal to 0. And you got, what, 15? So 15 plus 3 is 18. Modulus 3 is equal to 0. So then we would print what would we print? 3 plus 15. Alright, so then you got 20. 20 is less than or equal to 20. So you got 23 modulus 3. Yeah, modulus 3 is not equal to 0. And then you'd have what, 25? 25 is less than or equal to 20. And would you have, wait, 25 is not less than, so then you'd have, so that's done. So 4, and you have 4 less than 5. So you get 5. 5 less than 20, yes. So you got 4 and 5 is 9. So we got 9 modulus 3 is equal to 0. So what do we got? 4 plus 5. This becomes 10. 10 less than or equal to 20. 14 modulus 3 is not equal to 0. So we're done with that. Then we got what, 15. So what do we got? 4 plus 15 is 19. Modulus 3 is not equal to 0. Then we got what, 20. 20 is less than or equal to 20. So we have what, 24 modulus 3. That is equal to 0. So then that would be what, 4 plus 20. And then you got 25 is 25 less than or equal to 20. That's not true. This becomes 5 is 5 less than 5. Nope. And so you're done. So it prints all the multiples. So 1 plus 5 is 6. 1 plus 21. 2 plus 12. 3 plus 15, 4 plus 5 is 9, and 4 plus 20 is 24. Ugh, that's an awful question. That's a lot of work, actually. The rest of them shouldn't be that hard. Okay, so this one we got to do while loop. Cool. So A is 1 with a blank, and then plus 15 modulus 1 is, how many times is 1 going to 15? 15 times with a remainder of 0, so it'd be 1 and 0. Yeah, I don't want that. Come on now. Alright, fine. It wants me to stay there. I don't care. Alright, so we add 1 up. A become... Okay, so we add... So maybe it's best if we... maybe it's best we do this. Okay, so we have A, which is 1. And then inside of here we have an S dot O dot P. Okay, it prints A space and then 15 modulus A. Okay, and then it does A plus, okay, and then while, so we got ourselves a while, 15 divided by A is not equal to 3. Then it will run it again. So right here it prints, 1 space and then 0, like I said. So I mean, if we want to do something like that, 1 and 0. And what's 15? So 15 divided by 1 is 15. So is 15, not equal to 3? 15 divided by 1 is 15. So they aren't equal. So then, oh, wait. Before we got here, A became 2, right? Because we did A plus plus. So what's 15 divided by 2? That's, 7, because they're integers. It's not 7.5, it's 7. So those are still not equal, but either way. So now we got, what? 2. And how many times does 2 go into 15? It goes into it 7 times, and the remainder is 1. Okay, and then we got what here? We add 1 to it, so A becomes 3. So 15 divided by 3 is 5, and 5 is not equal to 3. Okay, so what does it do? It prints 3, and then 15 modulus 3 is 0, right? Because it goes in 5 times with a remainder of 0. And then we add 1, so 15, so that becomes 4. So what's 15 divided by 4? Okay, well, let's look at this. 15 divided by 4 is 3.75, but remember they're integers, so that gets chopped off. So this whole thing is really 3. Is 3 not equal to 3? No, it is. So that's done, and what it would print would be 102130. Okay. And last one. And by the way, I have the answers on the bottom of this whole thing, so you guys can look at that too. M is 1. So let's do that. M and S dot O dot P, print M, blank space, and what? M minus 1. And then what? While M is not equal to 10. First time through M is 1. So what do we print? We print 1, blank space, and 0. Is 1 not equal to 10? It's true, so M is still 1. It never changed, so I'm not messing with it. So 1 and 1 minus 1 is 0. And we got the infinite loop going on here. Okay, again, M never changes, so it's just 1 and 0 here. You know, and it's just dot, 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 and infinite loop. So, all right, and so, you know, the answers I've kind of put all the way down there, so you guys can look at them. But make sure you guys print this and try attempting it on your own. Okay, so this video's done.